Welcome back. We're doing the 2013 problem number 3, and this is for both the AB and the BC class. So we have a data table problem here. So what's going on? We have hot water, and we have a coffee maker. And the amount of coffee in the cup is given by a differential function c. And what does that represent? The amount of coffee in the cup. So that's what C represents. So let's answer the first question. Use the data in the table to approximate the derivative of C at 3.5. Show the computations that lead to your answer and indicate units of measure. You should notice that this is a reoccurring theme. They want you to understand to approximate a derivative, you have to use the average rate of change because the derivative is the instantaneous rate of change. So just as a quick example on the side here, if you had a data table with 3 points in the curve, you don't know what the curve looks like. So let me show you what it could look like. It could look like that. And you want to approximate the derivative at a point. So say you want the slope of that line. That would be the derivative at that point. Well, since we don't know the actual function, we can't do that. So what we do is we draw a line between 2 points around it, find the slope of that line, which is known as the average rate of change, or the slope of a secant line, and that approximates the slope of the tangent line. So conceptually, that's what you should be thinking. So that's what we're going to do for this. So I'm going to say the derivative at C at 3.5 is approximately equal to, now 3.5, if you look, is between 3 and 4. So I want to do the slope between 3 and 4. So that's f of b minus f of a over b minus a. And I plug in the actual numbers. So we have 12.8 minus 11.2 over 1. Now you do not have to simplify this. Makes it easier when you write the explanation later, but again, you could just leave it like that even in the explanation. But we get 1.6, and they wanted units, I believe. Yes, so I always say you should reread the question after you answer it. We approximated C prime at 3.5. Show the computations, so we did that, and indicate units of measure. So this part is pretty easy. I'll do it in blue. This C, if you look down here, it's in ounces. So here, we'll do ounces. And the bottom is time, given here, and that is given in minutes. So ounces per minute, part A, finito. Let's go to part B. Is there a time, t, between 2 and 4, where the derivative equals 2? So back to this example, suppose this was 2 and that was 4. They want to know, is there a time where the slope of the tangent line equals 2? So that's where, since we don't have the function to prove that, it's the mean value theorem. So basically, if this blue line here has a slope of 2, clearly this red line, as you move across, will have the same slope as the blue line, and that's called the mean value theorem. But for that to work, it's important to note that the function has to be continuous between the endpoints, including the endpoints, and it must be differentiable. In other words, no sharp points and no gaps, no jumps. So those must be clear. So you need to state those conditions of the mean value theorem at the very beginning. So that's where this statement here, C is differentiable. So we have differentiability, but it doesn't tell us it's continuous. But we should know if something's differentiable, it has to be continuous, because when we look for a function where it's not differentiable, we look for discontinuities or vertical tangent lines or sharp points. But if it is differentiable, then there must not be any discontinuities, so therefore we know it's continuous. So we're going to say since C, whoa, that was my E, since C is differentiable, I was going to use a shortcut, therefore C is continuous. So we have differentiability and continuity. Now we have to show the slope of that blue line. In this case, we want to go, let's see, between 2 and 4. So what we need to do, this whole region here, is there a point where the average rate of change is 2? So you could actually check between different points. You could check between these two, you could check between these two, or you could check between these two. And quickly, you can look to see if the slope of any of those is 2. Now, the first one we're looking at, between these two, 8.8 to 11.2, that's not 2. From here to here, 11.2 to 12.8, that's not 2. But when you go from here to here, that's a jump of 4. This is a jump of 2, so that will give you the slope of 2 that we're looking for. So that's what we're going to do. We're going to do 4 and 2. So I am going to say C of 4 minus C of 2 over 4 minus 2 is 12.8 minus 8.8 over 4 minus 2. That does equal 2. So what we've shown is the slope between 2 and 4. For example, that I know that's not 2, but we've shown that the slope between 2 and 4 is 2. Therefore, there's going to be a place where this red line, as it moves across this curve, is going to be parallel to that. So we are done. We have done the conditions. Continuity, differentiability we've shown. We showed the slope of the secant line, or the average rate of change, is 2. Now our conclusions. Therefore, and here is the part there, and here's the cool thing. All of this is what you were trying to prove. So you would place that exact sentence right there. Therefore, there is a time t when t is between 2 to 4 at which c prime of t is 2. Because that's what you wanted to show. So we've done everything we needed to. So therefore, we can just place that as our answer. Therefore, there is a time. That's B. Let's move on to C. Let me erase all this for you. Let me do some magic to get rid of this line here. Bam. Use a midpoint sum with 3 subintervals to approximate this integral given from 0 to 6. So we are going from here to here, but they want 3 equal subintervals. So 6 divided by 3 is 2. So our first subinterval will be 0 to 2, our next 2 to 4, and then 4 to 6. So midpoint. A lot of you, for some reason, have trouble with midpoint. I am going to draw a quick example of what midpoint actually is. So we have some data points. I'm not going to use the actual, take the time to plot these out, but we have some points. Like I said, these I'm just randomly picking points. Did I get the right number? 1, 2, 3, 4, 5, 6, 7. Okay, there's 7 of them. So the first interval is from 0 to 2, which is here to here. So what does a midpoint say? You're going to create a rectangle using the midpoint as your height. So we want the area of that rectangle. Our next interval is going to go from here to here. So basically, again, the same thing. You're going to create a rectangle, just like left hand and right hand. This is just a rectangle, and the height of the rectangle is based on the point in the middle. And then our last interval is from here to here. I'm going to use the middle point as the height of my rectangle. And then I'm just going to add the area of those three rectangles. So that's what's going on. So let me represent this for you down below. So part C. So we want to approximate 1/6. Now, this is a very common mistake, and I do it too out of carelessness. Forget the 1/6. You need to carry that out throughout the rest of the problem. Don't forget. So I'm going to put that first. So the area of the first rectangle, the midpoint, is going to be when t is 1. So it's going to be c at 1. That's the height of the rectangle. And the width is from 0 to 2, so it's 2. My next middle is going to be 3, because we're going from 2 to 4. So 3 is the midpoint. So that's just going to be, whoa, I messed up, didn't I? C at 3. And the width, again, is 2, just like the one before. I realized I messed up right there. Let me fix that. It's C of 1, C of 3. And the last one, we're going from 4 to 6. The midpoint's 5. So let's C of 5. Then let's plug in our actual values. So C of 1 is going to be something, 5.3 times 2. C of 3 is going to be 11.2 times 2. And the last one, C of 5, is going to be 13.8 times 2. That is our answer, but let's reread this. Use the midpoint sum with 3 subintervals of equal length to approximate the value, this one right here. So we have done that. Now we're not finished. Using correct units. So let's look at our units real quickly, evaluate this. So integration is basically multiplication. It's c times dt. All the integral does is add up a bunch of these, so you still have the same units. But the 6 down below, you have to realize this is the average value formula. This 6 is the width, and the width is time. So this is 1 over a minute. The units of C of t, if you look above, is ounces. That's that. And the units of t is minutes, or the unit. Those will cancel. So you're left with ounces. So our units for this problem will just be ounces. And that will make sense when we give the meaning in the context of the problem. So I'm going to erase that work I just did here because it might confuse you. So it says, using correct units, explain the meaning of this integral. You have to recognize this as the function to find the average value function. The integral of a function divided by the width is average value. Just have to recognize that. So this is the average value of C of t. So what is C of t? Look back up here. It's the amount of coffee in the cup. So tying all that together, you would say the average of C, which is the amount of coffee in the cup, so the average amount of coffee in the cup Okay, and it's between 0 and 6. From t equals 0 to t equals 6 is, and it's the answer we found previously. You could copy that whole thing down. Again, I don't recommend simplifying. If you did happen to simplify, it would be 10.1 ounces. So for this test, you're going to be allowed to use your calculator. So if you want to put that in your calculator and get an answer and then double check by just reading your screen, you're pretty safe not making an error, but I would double check to make sure you punch your numbers in right. And then ounces. There's the answer. And it should make sense because the average amount of coffee is going to be ounces. It's not going to be ounces per minute or ounces squared. That doesn't make sense. It's going to be a volume, which is ounces. So let's do part D. The amount of coffee in the cup in ounces is modeled by, so we have a new function that models the amount of function. So before we had a data table, now we actually have a function. Using this model, find the rate at which the amount of coffee in the cup is changing at 5. So B is the actual amount of water. Water or coffee. So it's a derivative. The derivative at 5 gives you the rate of change, the rate at which the amount of coffee is changing. Because if we wrote this in a differential equation style, we'd get dB dt when t is 5. So understanding this, dB is how fast B is changing, which is the amount of coffee. T is as time changes. So the dB dt is the rate of change of the amount of coffee with respect to time. So this gives you an understanding of what this is telling you and answers this question, the rate at which the amount of coffee is changing. So you just pop that in your calculator. So you would do math 8. I would put this function as y1. Wait, is this a calculator question? Actually, it's non-calculator, huh? Okay, so here's what we need to do then. First, we have to show that we can find the derivative of B. What we have here, that's box. So we take a look. The derivative of 16, derivative of constant 0. So that's going to be 0. Minus, okay, this 16 is a constant times a function. When you have a constant times a function, you copy the constant, you take the derivative of the function. But what's the derivative of e to the box? Well, what's the derivative of e to the x? The derivative of e to the x is e to the x, so I do that. But you have to multiply by the derivative box at the end, which is negative 0.4. So that's b prime of t. So b prime at 5, you would just plug 5 for every t that you see. That's a 4. And my t is 5. You don't have to simplify that. You can leave it like that. Now, for those of you crazy people that don't listen, if you did simplify, you would get this. Do you need units? Only if they ask. Let's double check and see. Apparently, it doesn't ask for that, so we are done. Bye.